and then hand things over to Stet, who's going to give you a whirlwind overview of everything we've covered in course. And then I will come back at the end with my own parting comments. So the couple announcements I have, one is I usually talk about the final exam today, but I chose to talk about that at length on Monday instead of today. So I really just want to remind you all that information about the final exam has been put on a B-Courses webpage. There's a link to it at the top of the homepage. Couple of things to put on your calendar. There's an exam review on Thursday evening, May 7th. That's during RRR week from 6 to 9 p.m. We will update details about that later. The exam itself is on Monday, May 11th from 7 to 10 p.m. Berkeley time. So I've written to you directly if you will have an alternative time due to time zone or DSP challenges. Otherwise, it is the same time for everyone. And then secondly, I just want to wish everyone luck with your design project presentations this week. I'll be attending at least a part of every section whenever I can, and really look forward to seeing everyone's work. Remember that your presentation is not just about what you produced in the end, but we really like hearing your story about what you learned along the way. And also remember the limitations of showing one slide at a time as opposed to when we had full boards and reviewers can look around and visually reference different drawings. So just keep that in mind and make sure you're always helping orient the viewer to what they're looking at. And with that, Stet, I'm going to mute myself and turn it.
I want to make sure everyone can hear me okay.
Yep.
Perfect. Okay, everyone. So first off, a huge thank you for sticking it out for this whole semester. It's just been a little crazy, I think, for all of you, for all of us. And it's been a very steep transition, I think, for all of us to realize what it is to work from far off locations in isolation. So just a big thank you on your side as students for being resilient and sticking with it. So I think when you get towards the end of 140, and this was the case when I was a student, when I was a GSI, when I was an instructor, when you get to the end of 140, it's kind of amazing if you look back at how much content is covered and how far you've come from your understanding of building performance. So we're going to do today a little fast style review of everything that we've come through and try to understand what that actually means for going forward and how to apply those thoughts as you move through the rest of your time at Berkeley and also as you move into the professional environment. One little caveat that I'll add is that we're in really uncertain times from a work standpoint, from offices hiring or furloughing folks because of the economic change. Any element that you have that can differentiate yourself as you guys go out into the world and look and sort of start your careers, any element that you can have to differentiate yourselves from the masses is a huge benefit when you are seeking a job, especially in tough economic times. And I will say that the growth in interest from large firms and small firms alike in understanding sustainability and building performance and the human factors associated with that will give you a huge leg up against somebody else. So I just encourage you as you think about when you're putting your portfolio together to be able to start highlighting your understanding of building performance alongside your really unique design skills. So with that, we're going to launch into a whirlwind pace. We know that everything is collapsing around us. It couldn't be more true now than at the beginning of the semester. But with increases in population, the climate is taking an impact. And associated with that are the health impacts with emissions that make you more susceptible to pandemics. All of these things are intertwined, and all the topics within 140 are really part of an interconnected web where each piece actually influences the others. We've learned about where industry uses energy from buildings, transportation, manufacturing, embodied carbon to operational carbon. And at the same time, we fully realize that we can't just shut down the world to stop our emissions. I think right now, with everybody staying at home, you've seen a really robust reduction in emissions, but it's not sustainable for everybody to stay home and hold up. There are a lot of jobs that require being out in the world and energy to be used. But the role for us as designers, as engineers, and as architects is to actually apply that energy in the most efficient way that we can for the lowest emissions, and try to look at one more holistic solutions from the energy standpoint. We learned about impacts to health. This couldn't be more applicable now for our office in particular, as we're doing a lot of work with hospitals right now to rapidly transition them from ICUs into isolation rooms. A lot of the elements of health and building efficiency and emissions actually go in and have a direct impact on your body's ability to fight infectious disease. And so there's a correlation between the stuff that we talk about 140 and the impact in real people's lives. We talked about thermal comfort, how your body begins to sense energy, temperature, humidity, air flows around you, and how buildings can begin to respond to that through reactions in shading and facade design. And we talked a little bit about occupant surveys, post-occupancy evaluations, and trying to learn from the workplaces. Some of the exercises that you guys did in lab are actually adapted from real POV processes that we use in life. And Gail talked about thermal delight versus thermal neutrality when we talk about thermal comfort, variations in space, and trying to get away from this idea that steady state is normal, because we know that it's not. We folded in ASHRAE thermal comfort standard and the expanded thermal comfort study or standard. I can tell you right now that I use this, granted I'm a mechanical engineer doing heating and cooling systems, but we use the standard every week on every project. And a lot of the really exciting work that we do is finding novel ways to maintain comfort with lower energy use. And sometimes that means thinking outside the box. But again, the robust work for you guys of understanding how the body actually perceives space from a thermal standpoint is really important. And it hopefully will change the way that you design buildings. We briefly talked about psychrometric chart, how to move around it, what it means for humidity and temperature working through the space. But I think one of the most important diagrams that we talk about in this class is the inverted pyramid. And so if there's one thing that you can take away, I hope it's this. And I hope that you think about this on every project, because I know we do in our practice, starting with the dumb and simple things about reducing loads, thinking about passive systems, how your building fits into the climate, your climate analysis, even your final project where you guys are doing climate analysis. It's not just about doing it and throwing it on paper, but eliciting out or pulling out from that data, what does it mean? What does it tell you about seasons, about different times of the day, and which passive strategies could really align with your location? We jumped into active systems, and I talked extensively about energy recovery, one of my favorite things, and then getting to net zero energy through renewable generation. So this is definitely one of the most sort of elements of 140 that resonate the strongest with me. We talked about how building massing has changed over the years, especially with the advent of air conditioning. Gail talked about that in the HVAC lecture. But understanding that we've moved away from these skin-dominated buildings that were really well daylit, very well naturally ventilated, and we've moved to sort of sealed boxes. And now there's a huge movement within the industry to sort of move back, which is really exciting to watch and get away from sort of the normative design of the dumb solution and the easy solution of just doing an all-glass building. We talked lots of case studies. I think if there's one thing, if before you leave for the semester, I really encourage you to download all the lectures if you haven't already, because there's a lot of case study projects in there that will give you sort of inspiration for the future. The Lucille Packard Foundation building is one that still resonates with me all this time, both as a beautiful building, but also a really low energy building with great responses from staff and faculty inside about how comfortable it is. If you go all the way back, super far back in the semester when we were talking about thermal mass, it even came all the way up until the balance point game in lab, understanding the role of materials in the building to store energy and to give you load shifting. So it wasn't just about comfort that we talked about at the very beginning, but also pulled it all the way forward into the HVAC lecture, our electrification lecture, where we were talking about load shifting, and that the building itself, the thermal mass of the building, can actually provide some of that load shift that we're going to need to design grid responsive buildings as we electrify and decarbonize our society. We obviously, there were some examples. I'm not sure if the Dominus Winery actually showed up in one of our thermal mass lectures, but it's a lovely project in Napa. It's private, so please, like, don't show up without an appointment. I tried that and got in trouble. But it's a lovely project that incorporates both elements of thermal mass, climate-specific design, as well as obviously gorgeous lighting effect and sort of daylight strategy. Another one of my favorite topics, we talked about thermal bridging. Of course, with all the ski resorts closing very early this year, I had wished that I had gotten to do more of this, but it's a great place to just reflect on what you guys know now about building facades and building elements. We tied that back to the three modes of heat transfer: conduction, convection, and radiation, and understanding how air movement across the site can actually strip heat off of your building. Those air films, don't forget, every U value that you calculate must include the air films. Air films are your little friend that should carry with you. For radiation, we talked both about the near infrared as well as the visible light portions. The infrared being that heat piece that we are trying to fight against or protect against. Those are a really key element. Briefly talking about the impacts of materials on radiation, so designing cool roofs in lieu of sort of dark asphalt roofs that we had historically, and how that can reduce energy and increase comfort and reduce heat island effect. That same radiation actually we can use as a tool. So I showed a lot of images of false color thermal camera images of looking at surface temperatures and trying to identify locations of air leaks or missing insulation or air ducts that are in the facade, which they should never be, but sometimes they are. And I know all of you thoroughly enjoyed covering series and parallel heat transfer and the house box that we studied for what felt like 7 weeks of starting with series and parallel heat transfer and moving into the understanding of what those assemblies are, doing therm analysis, or at least looking at therm and understanding its role in evaluating windows. But yeah, for the series heat transfer, all the lovely R values that you guys now have in heart. You know, what's the typical R value per inch of mineral wool insulation? Eventually, these things will stick in your head. You'll know that it's 3.4. You'll know that polyisocyanurate insulation is about R6 per inch at the beginning, but tends to degrade to about R5.5. Trust me, you'll love R values in your career. And this is just the start. 140 is just the start of being able to take those values and start building that library in your mind to be able to react very quickly about getting the most performance out of the smallest cost or the smallest carbon footprint or the best health of the material. We talked about the perfect wall systems. There was a lot of resources that we gave you during this section from Building Science Corp. Again, I would definitely recommend going to their website if you ever have questions on facade design. I also listed the resource of 475 High Performance Supply, which has a series of free books on high performance buildings that are low embodied carbon and low toxicity. So great resources. Again, pull those lectures down, use those resources. They're really they're at your disposal. And again, they'll set you apart at your office. I can't tell you how many folks that I've worked with over the years that don't have the 140 level of knowledge about building performance, and it gets them in trouble. And so you can really set yourself apart and drive performance and sort of human factors and health, and become the expert in the office that you go work at. Talked all about different types of materials for insulation. And when Sarah gave her lecture, she even folded in elements of health and toxicity with that. And when I talked about embodied carbon, we did the same. So there's lots of factors that complicate this decision. So it's not just something that you do once and forget and say, oh, there's the material of my choice. There's a lot of factors, and there's going to be more. So as you guys go out into the field, there will be more elements that you have to consider when making every choice. And I think that's sort of the resilience that you've shown during this whole pandemic is the same sort of resilience that you'll need in the workforce, to be able to take on new information and change over time, so you don't get stagnated. Again, talked about continuous insulation, blocking thermal bridging, and all the different sort of thermal bridging strategies. I think I shared a lot. We did calculations for infiltration, and this is the blower door test that we talked about, but designing buildings for air tightness, and then pulling all of that together into our whole building envelope calcs. Again, kind of truncated, shorter examples this year. We didn't have to do all of it by hand and iterate as much, but being able to pull in that full sort of UREF of your building that includes that perimeter slab and the infiltration and leakage. Taking that all the way into calculating your whole building energy use, and then ultimately getting you to this EUI, which is that label value that allows us to compare buildings against each other, regardless of square footage, because it normalizes against square footage, and gives you a sense of where you stand in the greater scheme of things. Are you a hospital? Where should you land from an EUI standpoint? Are you an apartment building or a school? You know, we can get benchmark data, but we can also design to be better than the benchmark. You know, my goal always for every project is to start with the idea that it must be net zero energy, regardless if they're going to do on-site PVs, but ranging that EUI to understand how you fit into the broader scheme is really, really important. Obviously, we talked a lot about net zero. I'm super passionate about net zero buildings or net positive buildings. And I think that as you guys sort of hit the profession, there's going to be a bigger driver from local codes, local states that are actually going to be mandating this as we decarbonize our society. I think one of the most exciting things, if you guys have been able to stay around in the Bay Area during this quarantine, is just noticing the drastically improved indoor air quality all around us. And if you're in any city, you know, I have friends who work in New York and Chicago, and even in Dallas, and everybody has noted that during this sort of pandemic, the air quality has been tremendously better. That people can see far off vistas that they haven't been able to in the past. And it just sparks in your mind, well, that would be the case if our economy transitioned to a low carbon economy or a zero carbon economy. If we had zero energy buildings without combustion, if we had transportation that was zero energy or all electric without on-site combustion, and our buildings had gotten there, all of a sudden you start to see that this could be our everyday, where you could see Mount Rainier super clearly. In the Bay Area, you could see Mount Diablo, or you could see past the Golden Gate Bridge out into the ocean. A zero carbon economy gets us there, and it has obviously visual impacts, but it has the health benefits as well. So once we calculated whole building energy use, we did peak load. We talked about energy simulation, energy models, how they work, and you guys got to test out Saphira as a sort of early stage schematic design tool, and trying to compare your building against sort of baseline, whether it's ASHRAE baseline or Title 24 Part 6 baseline. And you guys got to do some iterations. We still use Saphira in our office for some super fast, super dirty early energy models to get us in the right direction before we sort of bring out the heavy gun. So it's still super valuable tool. And if you actually can bring that skill set to your office, again, it's a differentiator in what will become a pretty tight labor market. One of Gail's favorite topics, and mine as well, passive cooling strategies, really working with the climate, with thermal mass, with night purge, all the strategies that really talk to setting your building in a place are really exciting. I think that any building that strives for passive strategies requires a fundamental understanding of where you're putting that building, and it makes that building extremely unique. It makes that building situated where it is, and it couldn't be anywhere else. And that makes for really exciting architecture. Lots of examples of beautiful daylit buildings, solar control, even examples from Berkeley's campus. This is the biosciences building that our office designed with exterior shading and diffusion layers to try to get that really nice daylighting. And that was supported by Susan Ubelodi and her office. Lots of examples when that's not done. It doesn't take a whole lot to drive around the Bay Area at all the tech offices and see lots of glassy buildings where the shades are fully drawn all day, every day, and all night, every night, because the spaces are overlit and they're not controlling for that sun and the glare, which you guys have been doing and learning how to do through SketchUp, through physical modeling, to be able to deal with visual comfort, daylighting, and solar control. So again, these are super useful skills. Ironically, we're getting asked now to come down to several of these tech buildings in San Jose and Santa Clara and retrofit them with better facades because the owners are realizing that they can't put people up against the facade to sit there because it's so uncomfortable and the glare is so strong. And so they're losing out on leasable square footage. So having skill sets to be able to understand solar control, solar geometry, and daylighting and visual comfort, again, will give you a leg up in helping your clients actually get the most out of the buildings that they build. Every year we do a little test to see how well you understand solar geometry. And in general, the class I'd say this year did pretty well. There's a couple hands here that are kind of pushing up in a few directions that might not be where the sun is, but I love this exercise, and I hope right now as you're sitting wherever you're sitting and sequestered in place, that if I asked you right now that you could point to where the sun should be and have a better understanding, because it gives you, again, a sense of place. If you sort of walk through the day, having these things in your mind, thinking about daylight, locations of the sun, it starts to help you situate yourself where you are and ground yourself where you are, and hopefully your buildings will be as well. Yeah, love solar geometry. Talked a little bit about the changing in quality of light across the day and the diurnal swing, looking at regions of the Arctic, which are defined by any location on Earth that has at least one day of 24-hour sun and a day of 24-hour darkness, versus the tropics, which generally have pretty equal days from across the seasons. And probably one of the only places in the world in the tropics where you could stand in a place and stand entirely within your own shadow with the sun directly overhead. We did a little bit of a lot of SunPath diagrams with digitally and analog, understanding when solar radiation is at its worst or at its best and how to leverage that, and then what window technology to bring to the game. So once you've done all your shading strategies, what are the strategies for looking at window technology and glazing, site horizon shading masks, which are really effective at deciding whether your building actually needs shading or whether the location of your building in itself provides the shading that you need, and talked about examples of that, including the Apple Store. Lots of shading masks. You guys are going to be experts at shading masks. You can drive shading masks. I will tell you that just yesterday, I presented a shading mask to a client to get them to begin to understand why the overhang on this certain building was going to need to be 14 feet. Because they had asked us for the CEO's office to never have direct sun on his desk. We showed him about 12 different shade designs that actually achieve that. And they picked the one with the super deep cantilevered, like super thin overhang, because then they could occupy the outdoor space for much of the year, as well as a sort of outdoor terrace. So I can tell you shading masks are real. It's not just a 140 thing. We use them in our office all the time. Understanding just lots of variety of shading strategies across the world. I didn't have time this year, but I have an entire slide deck of shading strategies from when I go on vacation. So you guys know I'm kind of a nerd. But whenever I go on vacation, especially if I can get a chance to go to Europe, my partner and I will go to as many buildings as we can, and then I'll document shading strategies for different climate zones. And it's a fun way to start touring lots of really nice architecture, and also inspire yourself to not just think of normative design. Daylight became a huge piece of the class, and for your project, the final project, and understanding just case studies for that, different times of day, qualities of light exercise, sort of really exciting. Understanding how light can pull out texture over the course of the day and give a dynamism to your project that you might not otherwise be able to get. We talked about electric lighting and not just daylighting. And I wish that we could have spent all the time that we love to do building big physical daylighting models. I know some of you guys have done it in quarantine, but it's one of my favorite things. Instead, we got to spend this year in our masks, quarantined away from everywhere, and not able to do our overcast sky simulator. So I encourage you, there are other overcast sky simulators out in the world that are available. And if your office happens to be near one, I encourage you to dive into it, because it gives you a really amazing chance to test your designs. Yeah, understanding different qualities of daylight, what daylight can do for your project to enhance it, make it amazing. Different lighting technologies, lighting systems, a little bit into lighting efficiency. And then we jumped into different materials. We talked about embodied carbon, what it takes to actually build materials, and the energy associated with that. Gail and I both introduced a whole bunch of standards around energy use, sustainability, both from LEED standpoint to Living Building Challenge, Passive House, the building code, all across the world, to understand what is the worst that you can build and what is the best. How do you strive to get even better? And a lot of those systems, like the Living Building Challenge and LEED and Passive House, are actually striving for that better and best. So we talked a little bit about sort of baseline codes, but how can you make your projects even better? And again, I don't want to harp too much on like what it's like in practice, but that's how we differentiate ourselves in the market, is that we go into interviews for projects trying to show them what the future could be, not what we've done, but what they could be. And it resonates with a lot of clients who are trying to strive for carbon neutrality and better health for the students on their campuses, and for the occupants of their buildings. The Living Building Challenge is obviously one of my favorites, having worked on a number of them. Exciting framework, one that keeps evolving and getting more challenging. And something for us all to strive for is for our, that circular economy that Sarah talked about, is the building that doesn't take much to build and can disappear at the end of its life with little impact. We gave some examples. The Bullitt Center, again, is one that we talked about a little bit in class, and it's one of my favorites. If you ever have a chance to go up to Seattle, they give free tours, I think once a month, of the project. And side note, if you go and on the tour, the last part of the tour is to go down into the basement to see the composting toilet system that serves the whole building, and they will give you a bag of human poop compost that you can take with you. It's very exciting if you like very low water use buildings and innovative design. I still have my, I have a couple bags of human compost to show clients. We talked a lot about all the elements that sort of go into the built environment, the WELL building standard as a place that expands beyond sort of built materials and goes into the quality of that space, the health of that space, and how it nourishes the body. I talked a little bit about the duck curve and what that renewables on the energy grid look like, and what the change in what our buildings will need to be when you begin designing buildings. That we're not just going to be focused on efficiency alone. We're not just going to be focused on slapping PV panels on buildings alone, that we're really going to have to think about how our buildings fit into the broader context of the grid and how friendly they are to the grid. We covered mechanical systems, HVAC, love it. It's going to be in every one of your buildings unless you design exceptionally passive buildings. We talked a little bit about the reason that a lot of our projects go into hydronic systems instead of air systems, the different components of the majority of the mechanical systems, air handlers, chillers, cooling towers, how that could be expressed on buildings, like the Pompidou on the left, but then also how if you completely ignore low energy systems, how good chunks of your building, as in an example on the right, where whole floors of the building are actually taken up by mechanical systems because there's no shading and the glass is relatively low performing. Some new lectures that you guys got this year that were updated relative to sort of very current situations are embodied carbon. So we talk quite a bit about the amount of energy and carbon emissions associated with building our buildings and how you can make choices to actually reduce that embodied carbon, which is really important because the time value of carbon is now. Now is when we need to really worry about carbon. So just doing a zero emissions building that saves carbon in 80 years isn't going to prevent climate change today. We really have to do that and focus on low embodied carbon materials. A great lecture from Sarah, a former GSI, amazing student, and pursuing her PhD on all the different aspects of toxicity as it relates to materials. This is something that as a topic area has been growing rapidly over the last 10 years. Whereas when I went to architecture school, we barely talked about it at all. I think the only green chemistry sort of discussions that I had when I was in school were like, oh, you should pick low VOC paint. And that was it. Like that was the entirety of the conversation. There's so much more information out there about the materials that we select for our buildings and how they impact the body, including not just respiratory issues, but also reproductive health issues. So extremely important area. And Sarah gave a lot of resources to dive into and a lot of topics to sort of think about as you go into design. Brand new lecture for this year was our focus on decarbonization and electrification. So I hope you enjoyed it. If you didn't, I'd love feedback. It's built on content that we're doing right now and we're using to help change the energy codes. So something that we're very excited about, but also something that's going to require dramatic change in how we design our buildings. So again, I can't think of a time that would be more exciting to be coming out of 140 as an architecture student, as a designer and a future architect or engineer, is understanding how your buildings fit within their context. So that could be through passive design and how your building sits on its site. But from a technical standpoint, it's how your building talks to other buildings, how your building uses energy at what times of day relative to your neighbors, and how do we collectively have our buildings work together to reduce our carbon impact, to move energy when we can produce it with really low carbon during the day in the summertime, and how do we conserve energy when it's really hard. It's going to be pushing us into a lot of work in storage, whether that's thermal storage or battery systems with PV. So I talked a little bit about microgrids and how we're using those to help load shift throughout the day, and even how certain mechanical systems like radiant slabs can be used to shift your cooling load throughout the day to what's ideal from a carbon standpoint. So each of these elements in the class, all the way from parallel and series heat transfer and thermal mass, facade design, daylighting, window selections, shading, all of those things come together to give us that toolbox that we need to effectively design really comfortable, compelling, and exciting buildings that also work towards this future goal of decarbonization, which is not really a future goal. It's kind of something we have to do right now, or the last 2 months that you've experienced and I've experienced of sheltering in place, pandemic response, that's only going to be heightened if we allow our climate to get even more out of control. So if you're looking for something to read over the summer, some uplifting, uplifting reading while you're alone, there's some great books that we could recommend. Drawdown is sort of putting out that plan to how we take our economy, flip it around, and reverse climate change. And then Enlightenment Now, sort of a goal of trying to get folks back onto sort of science and evidence-based progress. Before I hand it back to Gail, and I know Gail wants to give a huge shout out to our GSIs, your GSIs, for doing an amazing job and doing all the heavy lifting. So especially this semester, more so than any other semester, we're right in the middle of it. All of our well-formed plans that the GSIs and Gail spent all last semester preparing for and getting everything lined up, all of your assignments, all the lectures were ready, everything was ready, and then just like you, our lives were turned upside down. And a huge shout out to our amazing GSI team for being able to weather that, to being resilient to that change, and actually taking all of our course content with us and transitioning it rapidly to these super crazy Zoom classes that we're all in together. So a huge thank you and shout out to your GSI team, for which or without, we would have been struggling really badly to get through that middle chunk of the semester after we all left. So I can't thank the GSIs enough for helping with that process.
Thank you, and a big thank you to Stet.
Thank you.
Thank you.
Thank you.
Thank you so much.
Thank you.
Thank you.
Thank you.
Thank you.
So,
Stet, I just wanted you
Thank
to hear
you.
everybody.
yeah. And a big thanks to Gail for shouldering most of the oversight of the course.
Okay, so let's see. You have, if you will stop sharing your screen, Stet, and then I am going to offer my general parting message to you without any slides. So first, can you guys hear me? Yeah, Stet's giving me the thumbs up.
Yes.
Okay, thank you. So before I offer my general parting message to all of you, I want to start with some words of appreciation, and I'm going to begin with you, Stet. I have always enjoyed teaching with you, and although I missed your physical presence, I want to thank you for stepping seamlessly into this crazy remote teaching environment. You're such a great partner, and I think I can speak on behalf of the entire class that we greatly appreciate hearing about the lessons learned from your professional experience. I think it adds so much to this class. And students, in spite of the challenges of remote learning, I actually think you're all very lucky to be taking the class this year with Stet joining us. So thank you very much, Stet. We adore you. I also want to thank all of you, our students. It has been a great class this year. These were unprecedented times. I know that it's been incredibly stressful for everyone, not just academically, but I recognize the difficulty in navigating challenges in your personal lives. So I am grateful to you for your continued engagement. your willingness to ask questions both before and after the change. And while I couldn't always hear you, I hope you were laughing at our jokes. I've taught 140 for, let's just say many, many years, but this year will always be seared in my memory, along with all of you who took this very unique journey with us. And last but not least, before I offer my final thoughts, I also need to say something about our wonderful GSIs. You guys, we are so grateful for you. We hold such great respect and affection for every one of you. You put an enormous time commitment into this class every week. You would have done it anyway, but particularly this year, you consistently demonstrate your passion for the material and for education. You make a significant intellectual contribution to this class. You are a delight to work with. And wow, this year in particular, you are all my heroes, and 140 simply would not be the same without all of you. So students, I'm going to unmute you again to join me in a huge thank you to all of our GSIs.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you, Gail.
Okay, you guys, you GSIs, you're amazing. I don't know what we would have done without you. And I know how appreciative the students are. Okay. So we covered a lot of material in this course. Stet, that slideshow was just amazing to remind us all how much we actually covered. So what does it all have in common? The answer is really, I think, just in the title of the course, energy and environment. So whether you're going to be architects or other supportive members of a design team, you have an opportunity to manage, shape, and influence the energy use of your buildings. And through this, both the mitigation of climate change and the quality of the natural environment. But you also play an important role in shaping the physical and environmental qualities of the indoor environment of your buildings. And a big premise of this class is about that connection between energy and indoor environmental quality and our comfort. And we argue in this class that they are inseparable. You cannot have a high performance building that might consume low amounts of energy, but be a terrible environment for the occupants. If that happens, the energy saving strategies you incorporate in the building will not be easily replicated, and we will not have the transformation that we so desperately need in the marketplace. But another reason these issues are so tightly linked is that a lot of building owners may not actually care about energy in the environment, but they will likely care about people. So you can argue from your values, but you need to know about your audience. And I would argue that these experiential qualities are very often the inspirational hook for both you and your clients. So here's the funny thing about this. You will influence both the energy and environmental quality of your buildings, whether or not they're a consideration for you when you design. And you can influence them in a positive way or a negative way, depending on whether you actually do consider them, and especially in the very early stages of design. Now, as architects or other professionals in the building industry, your challenge is to find formal opportunities to do this as an integral part of climate responsive, energy efficient building design, not as an afterthought or a retrofit or something you just hand over to your engineers. And there's no doubt that there are an increasing number of really important technologies that help us in reducing energy use in our buildings. But in this class, we're emphasizing that the architectural form of your buildings should exhibit some of the same level of sophistication. That's the top of the inverted pyramid, the triangle that we keep referring back to. It's not just about the equipment. You need to begin with a building that works well. And we believe there's a positive side to this challenge. In fact, an opportunity to you as architects or other professionals in the building community. So in addition to what we've taught you in this class about what to do in terms of strategies, For my summary, I have a list of Gail's top 10 things I want to also leave you with some thoughts about the how, in terms of a mindset I want you to have. But confession, I counted, it's actually 8 rather than top 10. So I guess for next year, I better add 2 more. So number 1, starting with the important role of people. We encourage you to begin by looking more critically at what the occupants in your buildings need and value. Naturally varying daylight is actually better for most purposes than electric light, whose main benefit is merely its reliability. Studies have shown that natural ventilation and air movement are preferred over the constant uniform conditions we create through air conditioning. And there are wonderful, inspiring, form-generating opportunities that come from designing for both daylighting and air movement. And these are mostly in the domain of the architect. So by starting with needs of people as examples, we encourage you to promote a fundamental paradigm shift in the way we even think about the interior environments in those early stages, where we move from space-based to more localized people-based conditioning that provides people with various forms of personal control and adaptive opportunity. We encourage you to start explicitly employing rather than avoiding air movement, which we believe is an underutilized characteristic of the thermal environment that can allow us to simultaneously improve comfort and energy performance. And we encourage you to think about thermal landscaping or experiential landscaping, where subtle variations in our sensory experience can move us from neutrality to delight. So number 2, how does all that translate into an architectural response? Well, we've covered a lot of details in this class, and Stet just went over them. So my purpose in point number 2 is not to go through everything, but just a couple high-level thoughts that relate to this mindset that I'm talking about. For commercial buildings, for example, we would encourage you to consider moving away from curtain wall technology with sealed floor-to-ceiling glass, which basically turns buildings into greenhouses. And instead, think about windows that respond to the climatic needs, that purposely and thoughtfully focus the view and create this more human scale connection with the outdoors. Another example of that human scale connection in residential or smaller scale buildings is, we've talked a lot about thermal mass, but we encourage you to use these thermally massive thick walls where appropriate, and not just to moderate the more extreme temperature swings of the outdoor climate, but for a personal experience level, the thick walls can create natural window seats and these deeper angled window sills that create beautiful gradations of light, and many other details that bring character to the inside of a home. And personally, I would argue that a lot of these aspects of climate responsive design that are real person-based design are potentially much richer than those informed only by imagery or theory. Number 3, we encourage you to think broadly about the kinds of buildings you might want to work on. So while it's exciting to work on new building design, and that tends to be the focus in our design studio, our existing building stock is really where the heavy lifting is going to have to occur if we want to dramatically reduce carbon emissions from the building sector. And that absolutely needs to be a driving focus of the building profession. And we know it's also really exciting to work on high-end buildings where you can incorporate all the bells and whistles. We really need to expand our focus to encompass social equity issues, consider the social well-being of people and the communities we create, and incorporate these leading-edge green building practices not only into the Class A office space or institutional buildings, which might be the important pioneers to demonstrate their feasibility, but also in buildings that can be occupied by everybody, and particularly affordable housing. Point number 4, we encourage you to think about true building performance, not just checklists. And you know, the number of rating systems out there are increasing at a mind-boggling rate. And I showed you one slide with a couple of slides with just increasing numbers of them. So absolutely use those as a framework, but guide the conversation and decision making towards what will work, not just the point chasing. All right, point number 5, we encourage you to think about the life of buildings you create after the design is done. Too often, we see changes during the construction and operation phases that result in buildings that do not work as you may have intended in your wonderful designs. And building managers and occupants might not understand how the architectural and mechanical systems were supposed to work, what their role is. So stay involved. Get to know your contractor, work closely with them. Get to know the building operating staff and check in with them. Go back and visit the building, whether or not it's part of your design fees. Just do it anyway, because you're going to learn about it for your future work. Point number 6, we encourage you to use what you learned in this class to take a critical approach at the way you look at and evaluate the work of others. Be critical of what you see and hear. It's the Berkeley way, especially in this age where people are so quick to use sustainability buzzwords. Actively seek out the evidence for claims. Be on the lookout for alternative facts. You've gained so much knowledge in this class. Use it to form your own judgments about whether a building or a design is likely to be successful. And in doing so, we encourage you to broaden the criteria you use to judge whether a building is good or bad. So yes, absolutely continue to value aesthetics and composition, but we believe that efficiency and experiential qualities are just as important in making a building memorable. Point number 7, we encourage you to collaborate early and often. Making good architecture is a team approach. There's a reason we make the final design project a group project. It's hard, but it mimics what happens in the real world and what is necessary for making good buildings. We need to move away from this traditional model of a starchitect designing a building and then just handing it over to the engineer to figure out how to condition it. High performance design depends on an integrative design process where people with different backgrounds, skills, and roles in the project all come together, and very important from the beginning of the project, from the early stages, to identify and implement solutions. And even more importantly, they continue to communicate beyond that initial design charrette and stay together and collaborate throughout the project. And part of that leads to my tip number 8. We encourage you to respect others' voices in the process. We believe the profession is moving away from this model of the starchitect, a single person who's in charge of everything. You can learn from everyone all the time. So no matter what stage you're in your career, from an emerging professional to pre-retirement, don't ever think you know more than anyone else. But on the other hand, don't ever think that you don't have something unique to offer, because you do. If you hear architects being dismissive of engineers or engineers being dismissive of architects, don't buy into it. Be respectful. Be the one to stand up to it and be the respectful voice of reason in the room. And you know what? It doesn't matter if other people in the room have more experience than you. If you communicate in a manner that is showing respect for others, then you'll be respected. So we encourage you to always take the high road. And I believe this is more important now than ever, not just in the building profession, but in society at large. Our society has become so divided and so divisive, and we need to find common ground. We can't be dismissive of people with different views. We need to talk to each other with respect and an open mind. We need to build bridges, not walls. And I have so much faith in the youth and all of you to be our leaders in changing that mindset in society. So that was my top 8. I'll make it top 10. I do have some final thoughts, so maybe this can be like 9 and 10 combined. So in closing, what we really try to give you in this class is, I like to think of it as principles, tools, and values, and the relationship of all of those to design. So the principles, that refers to the technical information. The physical principles that govern the thermal and luminous performance of buildings and how people respond to those environments. And it's this fundamental knowledge that's going to give you an intellectual basis for design decisions and for evaluating buildings. And it's this fundamental knowledge that's going to enable you to understand any new technologies that are inevitably going to be introduced to the field, maybe new forms of insulation, technical advances in glazing, and enables you to understand them. Tools. Tools are the calculation and modeling techniques that can be a very real part of your design process. Whether it's the ability to do quick calculations or simulations to understand the performance of different materials, using sun path diagrams and shading masks, which Stet tells us he still uses to this day to understand the sun and shadow patterns on your site, from the surrounding landscape, on your windows, from the envelope and shading devices. The daylighting models, and this semester more than ever, we learned that even without access to an artificial sky, they can be really powerful in understanding the qualitative characteristics of light in your spaces. So these tools and more that are going to become available to you will help you evaluate the thermal and visual needs of your building and enable you to design and predict and evaluate the success of your building. And they can be simple or complex, but even the simple ones can be really powerful. And we hope you'll continue to use them and seek out additional tools. And we regularly hear back from former students who are using these tools in the field. So it's not just STEP. So this leaves us with the values. And I believe these are perhaps the most important and the most fundamental thing we hope this course has offered you. Hopefully, we've changed the way you think about and even look at buildings. We hope we've given you a greater appreciation for the role that you can play in affecting energy use and environmental quality. So we hope you take these values with you in your future endeavors, whatever career paths you choose. We have diverse students in this class. And when you talk to your peers and your colleagues, and taken together, what we've tried to give you in this class is both the inspiration and the ability to take pride in the creation of buildings that are both beautiful and efficient, that are responsive to people and climate, that are sensitive to the environment, and are a delight to be in. So you have all been a great class, and we all thank you. And I'm going to unmute because I hate just ending the class in silence. Thank you to all of you.
Thanks, Gail.
Thank you so much.
Thank you so much.
Thank you.
Miss you all. So weird.
I'm good. I'm good.
Amazing.
Thank you for your comments. And very grateful to those of you who have reached out to the GSIs. Make sure you tell your GSIs how wonderful they are and how appreciated they are. They work their butts off.
They make this class actually happen.
It would not have happened. I adore every one of them. Thank you for the comments. Thank you, Denise. Thank you, Sarah. Thank you all. All right, I'm ending the meeting now.
Let's save the world.
I'll see you all in section. Bye-bye.
Bye.